1, we did a confidence interval, and we knew the population standard deviation. They gave us sample of n size 35, 92, whatever. They gave us the sample mean, but they gave us the population standard deviation. Now the difference between 6.1 and 6.2 is this. The population standard deviation is unknown. Everything else will pretty much work the same, except when it's unknown, instead of using a z distribution, we will use a t distribution. Everything else we do follows the same path. Okay, we find the critical values, just like we did the z, we'll find the t ones. We set up your confidence interval. There's a calculator step. You probably didn't see it because z interval was sitting at the bottom of your screen. The next one is t interval. We can also use inverse t instead of inverse norm. Your inverse norm, normal z-score. We can use inverse t. Or their table in the back is on probably like A17. I'll get you guys a copy of it. It's A18. If you turn to A18, yes, right before the blue is the table. A18 is a sample of your t distribution chart. Yeah, but it's even easier. If you look at your chart, do you see the top where it says level of confidence? We're working across the top of the chart. It says level of confidence, 0.80, 0.90, 0.95, 98, 99. A18. The one tail, the two tail, that comes in another section. But for your part, for confidence intervals, we use the level of confidence. We use the level of confidence, and if you look down the left-hand side, we use degrees of freedom, which is one less than your sample size. So you're going to pull out one number. It's going to be a plus or minus that one number. It's even easier than your A table, because there's no negative side, positive side, or degrees of freedom. Will work on degrees of freedom. So, all that I want you to know is, to start with, is that your population standard deviation is unknown. We don't know enough about the population in the past. What happens is we also sometimes get a small sample size, and to work with a small sample size, we use a t distribution. They should have also included the small sample size with that, but for some odd reason they do that in their examples. So your random variable has to be normally distributed, but your population standard deviation is unknown. So we use a t. What happens is a t distribution gives us the same interval as a z, but slightly wider. Because if you didn't know enough about your population, you need to have a little bit more wiggle room in your confidence area. So it turns out that this confidence interval will be slightly wider than your z-score one. Okay. So now, the properties of your t distribution. You have a mean, median, and mode. It looks like your old curves do. Mean, median, mode in the middle. It's bell-shaped, it's symmetric. The area under the curve is 1. The tails, this is important, the tails in the t distribution are thicker than those in the standard deviation. And the standard deviation will vary in your t, but as the sample size increases, you'll see it come more together. What happens is, if you look at your book, if you look at the bottom of page 310, you see a series of curves. What happens is, this is one curve. Well, it should be flatter like this. And then another curve will go a little bit higher than that. And then another curve will go a little bit higher. It's a series of curves as the degrees of freedoms change. So do you need to know that? No, but you need to worry about degrees of freedom. Now, degrees of freedom are the number of free choices left after a sample statistic, such as the mean, is calculated. Degrees of freedom is like this. Did you ever play musical chairs? Okay, and they keep taking a chair away. Everybody gets everybody gets a choice where to sit except that last guy. He's like stuck. Yeah. Even if I had 24 chairs in this room, and I lined you up in the hall, and I said one at a time, come in and sit down. Do you get a choice when you come in?
Yeah.
Does everybody get a choice? No. The last person does not get a choice. So that last person lost his degree of freedom. So what happens is when we do degrees of freedom, it's n minus 1. That last person doesn't get a choice. Okay? If you have 14 in your sample size, 13 get a choice on which they pick. The last one does not. So degrees of freedom just says take your sample size, subtract it from 1. If you look at your table, that's the one down the left-hand side, degrees of freedom. Will these look much different? No. These are your graphs, and the shape of it stays the same, but it gets a little bit narrower each time the degrees of freedom increases. And as it hits 30, after it hits 30, it's the closest to your normal curve. That's why 30 is our cutoff. Okay, your table 5 lists your critical values. So let's see how we look these up. This is even easier than your z-scores. To find the critical value for TC, we call it instead of ZC, we use table 5 on A18, and we say for your 95% confidence interval, 95 of it sits in the middle. Our sample size is 15. So what's your degrees of freedom? 14. Always 1 minus. Now, with the z-score, we had to subtract it from 1, divide it in half. We don't have to do that. If you go to your table and you look up level of confidence on the top, 95, degrees of freedom, 14, and pull up this number right there. Everybody look at their table. They give you a little excerpt in the front of that on page 311, but use your table. It makes it much easier. 95 is right across the top. Degrees of freedom, kind of remind you, it's not your sample size, it's your degrees of freedom. So you see where it intersects? Good. So it's a negative 2.1.5 and a positive 2.1.5. And when we do the ZC, we left it as positive. We will leave this guy as positive. Now, there's a calculated step, 2.145. Did I say it wrong?
7.5.
I might have been talking too fast here. Degrees of freedom. That's where the minus 1 comes from. Okay, try this one. Try finding your critical value. It's not on your phone, Damani. It's in your book. Your critical value for a level of confidence of 90% and a sample size of 22. So what degrees of freedom are you going to look up? 21. N minus 1.
22 minus 1 is 21.
So what's our critical value? Find across, it's not on that, you have to look at the big table.
Okay. 90, so you go to 90.
90. Degrees of freedom. 21. 1.721.
5. Oh yeah, 1.721.
Good. I think the table is easier than the inverse norm, but I'll do inverse norm with you. Okay. On your calculator, do you know where you see inverse norm? You see underneath it, it says inverse T. This is inverse T-score. But you need to do the same thing that you did with your inverse norm. You have to say 1 minus 0.90 divided by 2. And I have to say, I'm stringing mine out, so then the next part is the mean is 0, the standard deviation is 1, And, oops,
I didn't get
I missed an argument. What does
I
yours
did
say?
not get that.
Yeah.
You got a
Mine is
double,
closer to
you got a
the
double
Oh,
parentheses
degrees,
at the front.
degrees of freedom. That's all it says, degrees of freedom?
Yeah, it doesn't have area.
It doesn't have the area. Sorry.
BF would be what,
21.
21.
That's all you need. And it takes a little bit longer. And you have to round it, of course. It gives you the negatives, you need the positives. I think it's harder in your inverse T than it is in the table. You have the software, so it's set up for yours. It'll say, but you just still have to do the 1 minus divided in half. When you go to your table, you don't have to do any of that. You just look up your confidence interval, your degrees of freedom, and you find your value. Okay? But for those of you that like to use that, the software is better on your phone, on your calculators, so that you can see it better. Setting up a confidence interval is the same thing. We're verifying that this is unknown and that your sample is either randomly, your random sample is normally distributed, or your sample size is greater than or equal to 30. Everything is, your sample size is random. I have a really bad headache today. I'll blow up on everything. So you're finding the same things. You're still going to do this. You're still going to get to this. We just find your margin of error a little bit differently. And here's your margin of error formula. What difference is it from your z-score margin of error formula? TC, and what else?
The S.
Yes. What does the S stand for, you think? Standard deviation from where? Population is this guy. Sample. Because this is when your population is unknown. So we have to use our standard deviation from our sample. What happens is it will give us a little bit larger of a margin of error.
How do we get that?
How do we get that? It'll tell us that.
Oh,
It'll give us that. You know how it used to give you your population standard deviation? It now gives you your sample standard deviation.
alright.
Okay.
You want that
So let's take a look at one. That'll ease all your minds. So you randomly select 16 restaurants. There's your N. There's your N. Pull out your information. And you measure the temperature of the coffee sold at each one of these restaurants. They did us a sample, means, come on guys, and a sample standard deviation of 10.0 degrees Fahrenheit. Find the 95% confidence interval for the mean temperature. Now, remember they had to tell us that either it was normally distributed or it was greater than or equal to 30. Is this greater than or equal to 30? No, I need to see it's normally distributed. So they told us that. Okay? So, first step, TC. How do I find TC?
Subtract 1 from
1, okay. Degrees of freedom. Confidence interval. 0.95. Find me your TC.
that.
What'd you get?
1,
2.131. They have 3 decimals. Okay? The rest is just fitting into your formula. Sample standard deviation divided by the square root of how many you have. Same thing with your z-score. You put the whole thing in your calculator just like you read it. And you find out your margin of error. The rest is basically the same.
It's exactly the same, except
It-
you changed TC.
The TC, and we have a sample standard deviation. That was his grown-up voice. So there's your margin of error. Okay? And you're going to find your confidence interval. 162.0 plus or minus 5.3. And again, you subtract it and you add it. 167. Am I right on this? Okay. Now, your calculator also does this. So if we go to your calculator, and we go to stats, and we come down over to test, you probably didn't see it because Z interval is the last one on the screen. But if you go past the Z, there's a T interval. We're doing a confidence interval with a TC. The rest is the same. It asks you for your mean. It asks you for your sample standard deviation. It asks you for your N. You give it N. It'll figure out the degrees of freedom. You give it your confidence interval. And it tells you what your, you give it your confidence, and then it'll tell you what your confidence interval is. Now, you can also take this and go backwards. You can subtract the 162 and come out with 5.33 margin of error. It does all this for you. Now, some of you are getting real good with the T interval, the Z interval. The T is exactly the same. The rest of it's transparent to you. You didn't have to find the TC. You didn't have to worry about your degrees of freedom. It does that for you. Yes. T interval, not test. It's got to say interval. You're doing a confidence interval.
How did you say to go backwards again?
To find the margin of error, just take your mean and subtract it off the high end. Remember, your mean falls in the middle. So the difference between the middle and an endpoint is a margin of error. Okay. You go to stats. That means you already entered your L1 table. Let's say they gave you a bunch of data, and then you entered it all. The calculator can go off the data and figure out its own sample standard deviation. Good, right?
Yeah. You want something?
No, thank you. I just took that. Oh, thank you. Okay. Now, I want you to try this. What we get for a TC for 90 degrees, up to 90% at degrees of freedom 15? Anybody look that up? 1.753. We're going to multiply it by 10 divided by 16. So what do we get for a margin of error?
4.383.
4.38?
Yes.
I rounded up to 3. 4.383.
4.383.
Okay, so we're going to make this at 4.4. This is one decimal place. We're going to round it to 4.4. Let's do it for this guy. What's the TC for this one?
TC 2.947.
Thank you. So your margin of error comes out to be what?
7.37. Okay.
So what happened here to here? What happened? And look at your 95 is right in the middle. Let's put 95 in the middle here.
Right in the middle.
What happened as your confidence level went up? What happened to your margin of error? It increased. It got bigger. So what's going to happen to your interval? Widen.
Oh.
So your interval will widen because your margin of error increased. It gave you more wiggle room in there. So it widened your confidence interval, just like it did with the Z-score. So when we find these guys, 162 plus or minus 4.4. So we should get 157. Nope.
166.
Okay, and then this guy over here should be 154.6 and 69.4. Let's do these out on a number line because when we look at these, they're so close, but there is a difference when you put them on a number line. So let's start with the 90 guy. 157.6, 166.4. This is my 90%. Let's do 95. 156.7. Do I find it to the left or to the right of 157? To the left. 156.7 to 167.3. So we see that getting a little bit wider. And the last one, 154, even further left. So, as the level of confidence rises, the interval widens. Not increases, widens. Okay, everybody do example 3.
All you do broke my heart.
Yep.
Wow.
All right, everybody give Mariah your undivided attention.
No, don't do that. Just so
It's difficult, yes,
because I'm left-handed, so
but it's probably better.
See, I was trying to rush so you could.
There'll be others, Damani, there'll be others.
Right?
Good, now notice how she keeps track of her degrees of freedom at the same time. She pulls out all her information. Good.
and then was shut up. That's for the teacher.
Mm-hmm.
Close.
It's divided by 2. That's how we have calculated.
You're up here next. This is sarcastic now.
I rounded up once.
Okay, you only have to round to the same amount of decimal places as your mean. So you can go, guys, do not pack it up. You can go to 2 decimals.
Tell them again.
Margin of error. I think you can leave this one for extra. Oh no, you can leave this one for this is over here. Sorry. Yep. 36. You get 1.19. Okay. Don't pack it up. Here's her 1.09. And her confidence interval, Mariah, this was very good.
I didn't get not. Wait. I got 1.1.
No, 1.1.
But round it to 2 decimals because these are rounded to 2 decimals.
I got 1.1.
So round it to 2 decimals.
Right.
Okay.
Right.
And there's your confidence interval, guys.
Yeah.